Welcome back, everyone, to Merge Conflict, your weekly developer podcast, talking about all things in the world of software development. And as I podcast, I'm actively writing code. Frank, look at no hands. It's just going. It's
Are you writing
happening.
code, or is your little robot writing code? James, I don't believe that you're writing code. When was the last time you wrote code?
Well, you just have been testing an app for me recently, a new Maui app that I've been releasing, my Pet Insulin Tracker 5000, and it's really good. Good. Yeah, that's a Sonnet, or that's a Claude 4.6 Opus SVG.
I thought you were going to say it was a human being. Okay. No? Okay. Yeah, it's basic, but all icons are basic now. So good for the AIs. Still got to get around to writing my icon generator app.
Yeah,
Don't steal my idea. Don't anyone take it. One's mine.
I'm pretty sure you could just do it right now while we're typing, like, while we're podcasting. You open up your OpenClaw and let it go to work, and then just do your thing. All right, we got a pretty good follow-up episode. If people listen to episode 501, where we talked about whatever we talked about last week, this week we got a special machine learning. However, Frank, I don't know if you know, .NET 11 Preview 1 came out today.
It did. I see, because well, A, my God, I can't keep up. I'm still porting all my apps to .NET 10. B, I heard discriminated unions are definitely getting into C#, 15? I can't even keep track of the C# versions. But and I heard that the Maui run experience is awesome. But that's everything I've heard about .NET 11. I haven't had a chance to install it because I'm still upgrading to 10.
Yeah, it's all good. I do want to. The only thing I want to point out specifically, as I was, doing a bunch of work, my team traditionally had just helped and manage a lot of the release notes and the blog stuff. We're pretty hands off now, and now everything's AI generated. Anyways, but
Stop it.
I will say, there is two big things for Maui developers, because we still got some Maui developers listening, I'm sure, that have been with us through our Xamarin days up till now.
So.
One, for .NET Maui apps, the new XAML source generators are on by default. Thank goodness. For good stuff. And then there's a new core CLR is on by default now. So goodbye, mono runtime. Bye-bye.
Never.
And then additionally, .NET Run has some brand new beautiful CLI commands. It's interactive. It allows you to pick if you want to deploy to iOS, Android, Mac. When you do .NET Run, it'll select your simulators and emulators. It'll show you everything that's connected to your machine. What a beautiful world. And I can't wait to use this. And that's going to be really nice, I think, actually, using it with agent mode and things like that. Elsa has to figure out these crazy strings and whatnot. So very, very nice. So definitely check that out. That's all we're going to talk about, because we have machines to learn, Frank Kruger, and they're learning and they're machining.
Well, I just thought it's been a while since we've done an actual machine learning episode. We keep talking about using AI and AI this and AI.com and all the. Did you watch the Super Bowl? It was AI ad after AI ad. So it's all good. Well, it's all important. We're going through the AI revolution.
Super Bowl. That's
Super Bowl.
Super football. Is it skating? Because it's they're in a bowl, or maybe it's like skiing or a snowboarding because they're in a bowl. It's a super.
You got to cover it in ice, so it's super. Because otherwise, it would just be mediocre. I mean, no one wants a mediocre bowl.
I heard it was a mediocre bowl, so
it actually
for about almost all of it, except for the halftime show, which was spectacular, and then the very 2 minutes or whatever when the Seahawks dominated. So.
Well, it's better than being stressed out the whole time. That's it. It's do you want to be excited? That's one way to watch a game. Or you could just be relaxed and happy that Seattle's winning. Wow, we diverged already. How many people did we just make mad?
A few 12s, probably.
Okay. I want to talk about machine learning because there's been a little bit of a revolution that I've been sleeping on. And I think it was new to me. And I'm excited by new things, as you can always tell in the show. So I want to talk about it. It gets back to our favorite topic. Speaking of icon generation, image generation. James, remember that topic?
Yes.
Before the LLMs, remember when we were excited about DALL-E? And remember how every artist is still mad at DALL-E? And remember how there's not one video on the internet now you can believe. You're like, well, that's fake. Everything's fake. That's
It's all
fake.
fake.
It's all fake.
Yeah. It's all fake.
I want to talk about fake videos. And I want to talk about why there's a bit of a revolution happening there, because there was a technical revolution that happened. But in my way, we have to go back in time first. Are you ready?
I would say yes, because I feel like you've been setting up like some sort of weird like Beatles analogy with like
Oh,
revolutions and going back in
oh,
time. You
that'd
say
be too
you want a
clever.
revolution. Na, na,
I don't
na.
actually know anything about the Beatles, so there goes
Which,
all my cred.
by the way, I just sang that. We just got to take down notice. So
Oh, good. Great.
yeah,
Yeah.
you're welcome.
Demonetized. There goes all our budget.
Well, don't worry because we're not monetized on YouTube. So make sure you like and subscribe and go there. Now, I think what's really fascinating is, yes, I remember when DALL-E came out, it was kind of this like revolutionary time and the stable diffusion, all these other things. And there's a huge divide in the world of AI generation in general, but also AI art generation. I have an artist friend, Ben, who was my officiant at our wedding, our
Hmm.
officiant at our wedding, more properly, but one of my best friends we worked at Crunch Time. And Ben was really cool because he's building a lot of board games. He's doing a lot of stuff. And he was like super deep into like the stable diffusion and the Discord and
Yeah.
doing all this stuff. And he was really, as an artist, really able to make this. I was looking at some of his decks and his cards that he was putting out in his games, these board games that he was making. I was like, oh, this art is so beautiful. He's like, all all stable diffusion. He's like,
Oh, good.
I like all of it. Once I mastered the art
Yeah.
of making the art,
The
I
new
made the
tool,
art. Yeah, he
the new
mastered the tool.
paintbrush.
And
Fantastic.
it was honestly because he's such a good artist. I didn't think that that wasn't my first assumption to be like, oh, this is AI generated art. I was like, well,
Sure.
you just and it's of course it's kind of like mystical and all these like
Hmm.
imaginary stuff. So it's not like photorealistic, but I was like, wow, it's like really good. Anyways, but that was like 2-3 years ago. So like 2 years ago, maybe
2 years. Okay.
3 years, three
Well,
years ago, yeah, something like
do
that.
you remember in the early days, might have been even pre-podcast, I did a presentation at our meetup in Seattle on these things called GANs,
Yeah, but
GAN. You remember?
nobody will forget. Everyone will remember your GANs presentation. GANs all day.
I feel
GANs,
like you're
GANs,
telling
GANs.
me something. GANs, GANs, GANs.
We did a
Well,
whole
GANs
podcast
were
on
important.
GANs. GANs for days.
Good.
Good.
I'm sure episode 50 out of 500.
I'm gonna look it up. I'm gonna look it up.
You can go find it. So GANs were really important. They were one of our earliest generative models for creating artwork. And I should preface this whole thing that I want to talk about, this whole machine learning is a new technique for generating images and generating videos. But I feel like I have to give a little bit of a background. And that background, though this isn't where the history begins, I just want to mention GANs because they were the first time we actually started getting some interesting artwork out of these AIs. And if you've never heard of a GAN before, it's a general adversarial network. It's kind of a clever concept. You have one network generating artwork and then another network critiquing it, saying, is that good? Is that good? Is that good? I don't know. Is that good? And the whole point was because you want it to be generative, you want it to be creative. I'll put that in scare quotes because people hate using the word creative with these things. It wasn't like a traditional machine learning problem where you have input and output and you can compare against the output. Because it's creating new things, you don't have an output to compare against. So what you did instead was you trained two networks, one that made the art and one that critiqued the art, the generator and the
Mm.
adversary. And that's all it was. It was a very simple idea, a very clever idea, a very brilliant idea, honestly, because you can use it to generate lots of things. So is that a good summary? I just summarized that should have been the whole 30-minute presentation right there, that 1 minute summary. Makes sense,
Opening.
right?
Yeah, and then but I'm pretty sure the presentation went on for a few hours. But besides that, yeah. But
Ouch.
no, I think in our year of February 2026, that's a great explanation of GANs. I like it. Yeah.
Okay. But that's not what we use today. There was a great revolution happened in around 2020. Do you remember what replaced GANs? It's part of stable diffusion. It's one of the words in stable diffusion. Diffusion
Diffusion.
model. Yes.
Diffusion model. They weren't, and they happen to be pretty stable.
Some of them. Well, actually, they were. So the problem with GANs was they were hard to train, really hard to train. In fact, I've trained a million of them, and maybe one of them worked out of that million sample. The trick is it's a really unstable kind of training environment because you have one thing learning to make images, and you have another thing critiquing them, and they're fighting. And if you get that fight out of balance, it just falls apart. We call it modal collapse. It became a real struggle, honestly. If you knew what you were doing, no, that's not even the truth. If you got lucky and you vaguely knew what you were doing, and you spent a lot of time and you pulled out enough hair and the moon was in the right phase and your zodiac sign was up, then maybe you could get the generator and the adversary to work together. But it was a real pain in the bottom. So this new thing, this diffusion came out. And the beautiful thing about diffusion was it was stupid easy to train. Any idiot could make a diffusion network. They were so easy to train because we came up with a supervised learning technique. You weren't training two networks anymore. Do you know roughly how diffusion models work? It's kind of clever. Do you know any of the theory behind it?
I think you explained it to us on a podcast, but it'd be great to have a refresher, Frank, just because, I know, obviously, but, there's probably some
Obviously,
new
you know,
listeners.
James.
I don't
Yeah.
want to spoil it for everybody.
So this is still the state of the art. Like, I'm pretty sure Dolly 3 is still a diffusion model. I'm pretty sure Nano Banana, all lots of the image generator out there are diffusion models. So it behooves you to know how these things work. So you start with a very noisy image. Or let's actually not even go there. Let's go midway through the inference step. So you have an image and you add some noise to it, and you train a network to remove the noise. Isn't that clever? Very simple thing. Because if you want to train one of these, you can just take a really nice image, or let's say a really nice video, or a really nice audio sample, add some noise to it, and then train a network to remove that noise. Seems simple enough, right? How hard could that be? It's a nice supervised learning task. You know the input, you know the output. This is why I say any idiot can train these. And obviously, I'm being reductive, but it's so much easier to train these than a GAN. And the real leap you have to make is, well, what if, James, I start with pure noise? What if I just start with all noise and then I ask it to remove the noise? Well, a little signal comes out. Maybe still noisy because it's an incredibly hard problem. And then what if I do that again? Oh, okay. It'll remove a little bit more noise and pull out a little more signal. What if I do that again and again and again? And you can imagine going from this thing that's pure noise, pure randomness, until it generates an image. It's a very clever idea. And you do that, let's say, 1,000 times. And you just incrementally, very slowly keep pulling the noise out of a noisy image. And what are you left with? An image. It's clever, right? That's super clever.
But there was no image to begin with.
Right.
Just
Isn't
noise.
that the mind trip? Yeah, you start with just noise. Yeah. So it's kind of neat because that noise in the beginning kind of, obviously, it influences what's going to be output. Then you have a second thing that influences your output. It's called the condition, and that's your little text prompt that you give it. So whenever you use one of these modern dollies or whatever's to generate an image, not SVGs, that's a different technique. We're talking about like bitmaps, images, pixels. What it's doing is it's starting with pure noise, and it's taking your little prompt, and that's just a condition. It's throwing those two things into a network, the noise and the prompt, and saying, remove the noise. It can't, obviously, because it's all noise. So it makes it a little bit more like an image. What image? Who knows? It's a big network. It's gonna make some decision. It's been trained to remove noise, so it's gonna remove noise. And then you do that 1,000 times. And you just very slowly pull out a signal from that noise until you're left with a beautiful image like an app icon.
Now, how does it know? I know it doesn't know,
Yeah.
but it's been trained on image sets and like what they are. So are there a bunch of zeros and ones that it's trying to like distill down to for all intents and purposes? Like, how does it come up with like, oh, here's a scene of a dog running through a forest,
Hmm.
right? Let's say that if that is just noise.
Right. Well, it's hard to say in that very beginning because, quite frankly, like it's kind of shooting off in a random direction in that beginning part. But that's kind of okay because we want the creativity. We want a bit of randomness in this thing. So let's not think about the beginning. Let's pretend it figured out the beginning and it's halfway through. So what do you have? You have a picture of a dog in a field that's a very noisy. Like imagine taking it at the wrong exposure level on a
Yeah.
camera. So you're getting a lot of noise, or it's a nighttime image. It's a very noisy image. You'd agree there that it can see, oh, there's kind of a dog, kind of a field. I'm going to find the noise and I'm going to remove it. You're kind of okay with that, right?
Yeah. Yeah. Yeah.
Maybe.
Yeah.
Yeah.
Yeah. I'm okay
So
with it.
just keep thinking it gets noisier, it gets noisier. So now it's having to do a lot more guessing at what the actual image is there. Um, but because it's working in such small increments, because it's removing just a small bit of noise each time, it can maybe there's a little dark spot in the noise and it'll turn that into one eyeball of the puppy dog. Or maybe there happens to be a tiny bit of a green section in the noise. It'll turn that into a tree. That's a bit of an oversimplification, but you can kind of imagine that as a model. It's easy to imagine the halfway point, half noise,
Yeah.
half signal. It can do that. So you just got to have a little bit of faith that in the early moments when it's mostly noise, it's just kind of picking kind of a random direction of what kind of image to generate.
Hmm.
You can
So
kind of see that working, right?
yeah, I think so. I mean, I think almost like it's kind of like when you used to do the Polaroids, right? Or like not the Polaroids, but the Polaroids, like you kind of
Yeah.
would flap them and it would
Don't
kind
shake
of go.
them.
Or
You're not supposed to shake them.
everyone does. Or if you went into a dark room, right, and you actually like it went
Yeah.
from like nothing and it kind of distilled down. It kind of reminds me of that mechanism. I still don't necessarily understand how it knows that it drew the thing that I mean, I know it doesn't know, right? It doesn't know anything, but it knows everything. But it doesn't know that it drew a dog running through a field because it didn't actually
Well,
draw anything, right? It just removed a bunch of noise
mhm,
to distill down to
right.
that dog running through a field, but like
Yeah.
just
So the dog
because.
running through the field, imagine it was trained purely on dogs running through fields, absolutely
Yeah.
nothing else. It's going to, in the end, generate a random dog running through a random field. The harder problem is when you have something like Dolly, where you want the users to be able to control what it outputs. And that's where you mix in the I want a dog running through a field, a brown dog, and it should be a puppy dog, and it should have something in its mouth, a tennis ball in its mouth. That's it does learn to get a tennis ball in its mouth because it's been trained on a million images of dogs with tennis balls in their mouth or tennis balls and dogs, and it learns how to compose things also. These are giant networks. They have so many parameters that they can actually figure this kind of stuff out.
Yeah.
So while its main task is pulling a signal out of noise, even though it could be pure noise at some point, it also has this guidance, this text prompt, telling it kind of what direction to go. Dog, field, tennis ball. Okay.
Yeah. Got it. So this is how like
So
modern things are working
this is
today, correct?
modern. This is, well, let's call this all the way up to 2022, 2023. And then a new revolution happened
No.
because there's a problem here. Diffusion is great because it's stupid easy to train and it's stupid easy to execute. What's the big problem? It's slow.
Super slow.
It's
Takes
so
so
slow.
long. Takes so
Oh
long.
my God, so long. So, I mean, you train these things to take 1,000 steps. So you have to run the neural network 1,000 times to go from noise to dog running in park with tennis ball in his mouth. And that is just inefficient. That
Yeah,
will
like
take forever.
even when I'm inside the Copilot app, the Microsoft Copilot app, like it kind of, funnily enough, kind of when you generate an image, it actually is kind of
Mhm.
distills down an image. It's all blurry,
Yeah.
and it kind of
Yep.
like goes from top to bottom. and it kind of like reveals itself in chunks, and like you can almost be like, I think I know what it is. What's it doing? And then
Yeah.
eventually like, oh, and then if you're like that's off track, and you can cancel it, but you like never know until the very final second. We're like, here's your image,
Yeah.
but it does take a while to generate.
It does. And if you have any interest in this at all, anyone who's listening, I highly recommend you download Stable Diffusion and learn how to get it running on your own machine, because it's
Mm.
really enlightening to see these things work. And especially if you catch them in that midpoint where it's still noisy and you're like, oh, what is it doing? And see how it progresses from there. I should say you train it on 1,000 steps, but in practice, that's even too many. Like, Microsoft has $1 billion, but they ain't going to spend $1 billion on you. So
Yeah.
they figure out clever ways to get it down to maybe 100 steps. So it's trained on to do 1,000 steps, but they figure out, we can take bigger steps. We can ask it to remove a little bit more noise on each step. So you train it for 1,000, you run it maybe 100 steps to do that. So
Okay.
that's state of the art, 2020 to
But
let's call it 2023.
But you just said that like that's how modern, or that's how like Nano Banana and all these other ones, and even like GPT-5 models like are
Yeah.
doing it. So like if
Yeah.
that was modern, why haven't these other like newer models and newer processes like evolved, I guess?
Because it takes time for big companies to catch up
I
to
see.
change their
I see.
approach. Yeah.
I see.
And
Okay.
because they have so much money and so much investment that they can get away with a little bit of efficiency. Because what I'm going to describe next is a new technique that everyone's using. But let me preface one more time. Imagine that for video. Imagine you want to generate a video. Now these networks are even bigger, and you're having to run them for 1,000 or 100 steps. Even 100 steps is a lot for a video. Like I think I forget what Sora does, but I think the like Facebook one is like 16 seconds at 16 frames per second. That's like
Yeah.
256 little images. And you have to do 100 to 1,000 steps on 256 images. It's a lot.
It's a
It
lot.
all adds up. Eventually, those are dollar bills Zuckerberg has to burn for you. So we need something more efficient. And this is where I finally get to the technique I want to talk about. And it's the perfect intersection of generative stuff and performance and speed, because these are the things I love. What if, James, I said to you, not 1,000 steps, not 100 steps, how about 10 steps?
I like
With the
that.
potential to get down to 1 step. How's that sound?
I'm intrigued.
Okay.
You've sparked
Okay.
my interest. I might VC fund this. We'll see.
Okay. So I should say Stable Diffusion 1, Diffusion. Stable Diffusion 2, Diffusion. Stable Diffusion 3, Rectified Flow.
Oh.
Rectified Flow. New technique, baby. New kid on the block. It goes by 2 names. Flow matching is the general purpose kind of technique. So you'll often see this thing called flow matching. But what everyone's actually doing is a thing called rectified flow. Ignore the names. I'll get into what they actually do and how they simplify the problem. But those are the big names you'll see out there. We know for a fact Meta's Movie Gen is using this. Stable Diffusion 3 is using this. Flux is using this. I think Midjourney's training one. So it's basically this technique. The research papers came out late 2022. 2023, people started to figure it out, started to write tests for it, started to, get a feel for how these new ones will work. So basically, anyone who's trying to save a few dollars will be implementing these. And these are basically used for videos also, because videos are so much bigger than images, obviously. So how do we do this? Well, instead of 1,000 points along that line of detect the noise, remove the noise, take a little step. Detect the noise, remove the noise, take a little step. That's the diffusion model. What if we just say, give me a noisy image, and I'm just going to remove all the noise all at once? I'm just going to say,
one
that's
shot
the
it.
noise. One shot this, baby. And what we're going to do is we're going to draw a straight line from noise to image. So we know directly this pixel needs to change this much. That pixel needs to change that much. That pixel needs to change that much. Do that for all the pixels. And the how much is called the velocity. Doesn't really matter. But instead of detecting the noise in the image, All we're going to do is detect how much every pixel in the purely noise image needs to change in order to produce a good image. And
Mm.
that's where the term rectified comes from. It's a good word that really just means linear path, a straight line from noise to perfect image. And we're going to train it in a similar way to diffusion. We're going to have like these partially blended image, a little bit of noise, a little bit of image. And at any point along that path, it knows straight line. Straight line from noise to image. No like detect the noise, subtract the noise. No. I see noise, I'm going to tell you exactly how
All
much to
right.
remove to get to the final image. And it sounds dumb and it sounds obvious and it sounds like, well, why didn't we just do that from the beginning? And that's because we had absolutely no math saying that that was at all possible.
Mm.
We had a whole bunch of math, a lot of theory around why stochastic differential equations, whatever, diffusion can work. We knew we could write noise detectors. We knew we could subtract noise. We knew that we could increase the signal to noise ratio. The big epiphany with diffusion was, what if we just do it step by step? So you could think of diffusion as start with a noisy image and keep searching around, keep wandering around this very large, high dimensional space and find an image out there. So we're moving from the crazy random world to a nice image world. And it's a
Hmm.
crazy path. We got to turn left on Main Street, right on Elm Street, left onto First Ave, all these kinds of things. But what if we just cut straight across all that?
A to
What if we
B.
just,
A to B.
yeah, what
As
if
the
we
bird
just go
flies.
as the crow flies?
There you go.
And that's the rectified flow. So instead of turning on all these streets, we just say noise to image. And you can imagine training was simple with diffusion, but now it's stupid simple because all you need to predict now is take destination image, take noise image, subtract them, because that's the
Yeah.
path we need to go on, and teach a neural network to come up with that number. It is the easiest. If I said idiots could train a diffusion model, monkeys could train a rectified flow model. It is so elegant in its training. And then I'll let you respond. But and then at inference time, you can see why you could almost one shot it. In practice, you take 10 steps, and I can get into why it kind of doesn't matter, but you take like maybe 10 steps because although we're trying to fly straight, we're not flying straight. There's a high wind, there's problems. But roughly speaking, you can just straight shot. Sounds
Yeah, I
good,
mean,
right?
in some aspects, right? Every image, every video, everything is just a pixel on the screen, and that
Mm-hmm.
pixel has an RGBA, and an HSL and all this other stuff, but an RGBA, right? Value to it, and if you're at one color, if you're at one RGB, let's use RGB
Yep.
for sanity.
All these networks use RGB, so it's perfectly valid.
If you're at RGB and you need to get to another RGB, there is simple
Add.
mathematics to add or subtract to those RGB values in general, right? You don't need to
Yeah.
slowly, gradually get down to like, I'm at brown and I need to get to green. Like there is a
Mm-hmm.
very clear deciding factor of that RGB color and what you
Yeah.
need to change it to. Now, I would assume that the computational part though is that if you're going to one shot it, you have to calculate all of those transformations up front though, of like to figure out what all of those changes are, which seems a little
Yes.
complicated compared to like we're gradually over time refining. Like it's kind of like you're
Mm-hmm.
polishing. Like I kind of think of like the distillation as like I'm polishing this, I'm polishing a rock. I got it in a
Yeah.
tumbler and I'm just
Yeah.
I was gonna tumble. I was gonna tumble. I was just how long have you been tumbling? I've been tumbling for days, guys, just tumbling. And then at the end, you have this beautiful, like, how is that rock shiny? That doesn't, it's a rock. But you're like, I just tumbled. I just tumbled
Yeah.
so much tumbling. But now you're saying, like, I literally, like, take my rock, snap my fingers, and now it's super smooth.
Yeah. This is probably a bad analogy, but it's more like you started with your rough rock and you asked Joe to polish it. and then Sally to polish it, and then Adam to polish it, and each person polishes a little different part, and you hope at the end maybe it comes out as like a nice Michelangelo or a David or something like that. Whereas the rectified flow is more like, hey, just make the statue of David. Let's just go for
Yeah.
it. Like, what if everyone's handed a little bit of a plan? And it's still interesting because we're still starting with noise. Like, it's still starting with pure noise, and we don't know, as people like developing these models, we don't know which noise is going to create which image. So we don't know that we want a statue of David in the end. Obviously, by a few steps through, we kind of see or it's looking like a dog in the park with a tennis ball in its mouth. That's why the technique in practice, you don't one shot it. You actually do you're taking a sloping path, but it's a very big difference between, like, diffusion is solving a maze, left, right, up, down. It's going in every direction to figure it out. Whereas rectified flow is mostly staying on a straight line, but veering because maybe we started on the wrong thing. Like, I want a dog in the park, but I started with the wrong noise. It's the wrong noise, man. I started at the wrong location. Like, you blindfolded me. And then as we're getting closer to the dog in the park, wow, we're really mixing analogies. Then you can start finding your way to that dog in the park. Yeah. Whereas diffusion's just more like, I don't know. You're still walking around with the blindfold the entire time. But the beauty of it is the performance thing. So I have been trying to, I'll take myself as an example. I have been trying to train diffusion models for years now because they are easier to train than GANs, although I have a lot of experience with GANs. But there's a lot of tricky math with it. And there's a lot of, we call them noise schedules, because technically you kind of have to work in reverse. You have to start with an image, add a bunch of noise to it, train a network to detect the noise, subtract the noise, and coming up with a closed form solution to how to add that noise without iteratively adding the noise, that's difficult.
Yeah.
You can't solve it end to end. You can't just have it like remove the noise at 1,000 steps and train from noise to image, because then you have the gradients disappear. It's just too big to train. The neural networks can't do it. So you have to come up with very clever math. And James, I love math. I love it to death. But I have the hardest time implementing diffusion math because it's tricky probabilistic math, and it's nasty. It's gross stuff. I hate that kind of math. Whereas rectified flow, you subtract the final image from the noise and you tell it that. Go on that path. Don't bother with any other path. Don't bother with any complicated math. Here's the path. Go on the path, Mr. Network. And it's so simple and it's so efficient that I'm back to being able to train generative models on my RTX 3090. Wow. It's back. The power is back to the people. So whereas OpenAI has more money than God and they can spend all that money to make you a Sora video, I don't. Compute still costs me, and I have limited compute, limited memory, limited math skill. But even now, I can get back into the generative game, and that's what makes me excited. I can start generating video again. I can start generating images. I can start generating audio. And I think we're going to have another explosion in this creative space, because it was just the big players that could afford to run these very expensive, very annoying diffusion models. And now with rectified flow, there's going to be more fake videos on the internet, and there's going to be more modalities, more senses being used. I can't wait for the smell generator. Like, it's going to be amazing.
Well, okay, so the performance is better, but what about like the actual quality of the image, right? Because, as image generation and diffusion kind of like went on, we're at this place now where there's a wide variety of models, right? If you use like image playground, you're like, well, clearly that's like a terrible. And then you use like some mid models, you're like, that's pretty good. Like they can, with the right prompt, they can do really good. And then there's some other models, like, everyone's all gung ho on the nano banana. You're like, wow, that's like really good, right? So what is the spectrum here that we're looking at for it?
It's better. What if I told you it's faster and it's better?
No, I don't
Does
believe
that
you.
not sound like
no? No,
All
I don't
for
believe you.
1995.
Oh
6
my
easy
gosh.
payments of 19.
Act now and get free shipping, and we'll put in
Yeah, a
we'll put in a
sponge.
yeah, sponge and a
A ShamWow.
katana. Wow.
Yeah. Yeah, it's one of those like how did we not think of this before? Well, we needed the proof in the math. That's what the flow matching thing happened to be. It's actually kind of funny. Two independent groups kind of discovered the same technique around the same time. It was late 2022. All these papers are published around them, and there were two independent groups that invented it, and they both came to the same conclusion. This is both more efficient and produces more uh, better. So what does better mean? Um, More diversity in the images, higher quality, and because it's more efficient, you can generate higher resolution. You can burn those GPU cycles on other things, HD, 4K, 8K. You can really start messing with this thing because let's say I was devoting 1 second of compute to generating an image for you. Well, now that the process is more efficient, now I can spend that on more pixels or doing video instead of images. So the creative quality has increased. And uh, I want to say there have been other advancements. Have you noticed how like text all of a sudden started working in these
Yeah.
kinds of networks? Yeah.
Yeah.
So there have been other advancements along the way that have enabled that, but with this core technique, you can add on those other modern advancements too. And so it's better, it's faster, and it's better. And that's why Stable Diffusion 3 has adopted it. That's why Flux has adopted it. That's why Meta has adopted it. The only people who haven't adopted it are the people still using networks they trained back in 2023, 2024 when this technique hadn't been established yet. So in 2026, this year, pretty much all the new generative models will be using a technique like this because it just makes perfect sense from a business point of view and from a creativity point of view.
Yeah. I mean, if you go and just search on the internet, Stable Diffusion 2 versus 3, that's pretty good. Yeah. I mean, it's pretty much better in almost all instances compared to Core versus the other ones.
Yeah.
I mean, the
And
other
that's
ones
kind
weren't
of,
bad necessarily,
no.
but they're better.
Yeah. Well, you see it like we were talking about that greeting card maker I was making using Apple's built-in image playground models. And those models are still so old they can't do text. So like
Yeah.
very early on we all figured out you have to be able to do text. And if you understood what I was talking about, how we're going from these noisy fields to images, I think you can kind of see why text was so terrible.
Yeah.
Because, like, at no path along that did it have any concept of this needs to be clear, let's say, English text in this font or anything like that. Input is not there. And so you can imagine. So we've had to come up with other solutions for that. But that's because all the difficulty was in getting these diffusion models working. Well, now that's passe. So I'm hoping like Image Playground, the next version, who knows, WWC 2026. Hopefully, we'll have models baked into these machines that can actually do text correctly because they will have spare CPU. They'll have spare GPU neural engine because hopefully they're using this more advanced technique, rectified flow versus diffusion, and then they'll have that spare stuff to use for good text rendering and other stuff and longer prompts and that kind of thing.
That'd be nice. Yeah, I could see that coming like a long way because the hope and dream would be, oh wow, like I'm on my machine
Mm-hmm.
and I could just use Image Playground or Chat GPT or Copilot or whatever. They could all have local models that are doing some stuff and just like do the thing, right?
Yeah.
And then it could just happen. And it could use the power of the neural engine and not to like go waste and burn a bunch of other GPUs. Always my
Yeah.
GPUs, you know what I mean, that are sitting here and doing stuff. Um,
Yeah. So
and
it's,
that could be pretty
and
cool.
if they're budgeting, I don't know how they budget this stuff at these big corporations, but let's say they're budgeting 5 seconds of GPU time per user per request. Well, if they have something that's 10 times more efficient now, then maybe they can generate 8 images in parallel, 10 images in parallel, because, you type in a nice ChatGPT prompt and you sit there and you wait your 5 seconds for that image to appear. It'd be nice if a grid of 4 images or 16 images appeared, and then you can pick your favorite from those instead of going one at a time and asking for another variation. So, I feel like all goldfish grow to the size of the bowl or to the size of the pond. Like, I feel like we're always going to be waiting about 5 seconds for an image generation, but now maybe it can be higher res or
Yeah.
more variations at the same time.
Yeah, and especially when if you get a better result the first time, like the goal there hopefully is that you don't have to regenerate the image, because what we end up finding out, like when Heather and I are generating images or even for the podcast, it's like it's close, but then I want you
Yeah.
to modify this one thing, and like I gotta wait.
Yeah.
Oh, you're so close. Like for me with like the podcast, even for episode 500, it's like I really wanted the 500 to be in the center, but like it just wouldn't be. But it was like so close. So then I like redo. I was like, oh, get a little bit closer. Then I like
Yeah.
threw it all away. And I was like, let's try it again. So often for me, the waiting isn't the hard part. It's when you got to wait like 10 or 12 times to get that
Yeah.
perfect image you're looking for. And I've noticed that the model's gotten better, especially with the prompts of getting a lot closer that first time.
Hmm.
But yeah, if you were
Yeah.
to get, here's a bunch of them that are going, and I've seen Copilot spit out a few images at a time now too. I wonder if they're doing something, but yeah, it'd be
Yeah.
really interesting to see.
Yeah. So, this is we're right at the cusp of this new technique being adopted. Google has a lot invested into Nano Banana. I'm sure they're not in the mood to train a whole network from scratch again. So,
Yeah.
it might take a little bit of time before these things actually make it out there. But it's really neat from a machine learning perspective, from people who like training networks like myself. This is a great new technique because it kind of gets the small players back in the game. So the open source
Yeah.
people are back, and it's always fun to see the stable diffusion people, because most of those models you can run on your own machines also.
Yeah.
So I highly recommend everyone go out and download those and play around.
Well, and what I think about as well in this instance, to kind of wrap up this podcast, is like what kind of scenarios in the future, a year from now, will we have, right? Then when we can do a lot on our local machine,
Mhm.
because, about like a year ago, yeah, about a year ago, 8 months, 10 months ago, I was building a bunch of little games, with Copilot, GitHub Copilot. And there would be a lot of like 3JS games or like little like snake games or web games or
Yeah.
even some Godot games. But the problem is art assets, right? Like
Oh,
in
yeah.
in theory, even to prototype. So a lot of it I would be like just draw stuff, right? Just draw geometry, which is the greatest way to like, prototype games. But at some point I'm like, I would really like a little person and a little thing and a little tree and a little whatever, right? But I could
Yeah.
never get it because I'm not an artist. And like, but if
Yeah.
I was to say, here's the game, go generate the art assets I'm doing them on my local machine. They may not be the final ones. Obviously, I would probably actually have a, artist, work on the important assets that are for the game, but it could get me a lot farther. And for some games, if they were like card games or like things like that, you could generate all of them. Like, why not? And
Hmm.
you could do it today, but then it'd be very tedious, right?
Yeah.
Whereas this, you could spin up tons and like generate the whole art assets for solitaire, right? And then it's like done, right? You
Hmm.
verify it and do a thing and a bunch of themed card decks and whatnot. But I would never be able to do that before. So to me, and when I say I would never be able to do that before, it's like, yes, I would be able to do it, but I don't have the time to do it. And like, or I want to spend the money on it. Because what I would do is like, it would just be, not something that would bring joy to my life. But if I could
Hmm.
prototype and build out really cool games that were like a lot more visually pleasing, that could be really fun. Or even just art assets for my apps, right? Like a great
Oh, yeah.
example is, yes, there's tons of great font icons that are meticulously canned, curated, but dang, it sure would be nice to have like some really cool, backgrounds on some of my things that were generated and put in, or just generate on the person's device on the fly. You know what I mean?
Yeah.
Um, so that could be cool. So that'd be
I,
really neat.
I, yeah, we'll get going, but I have to say that is 100% why I got into generative artwork. Was I wanted to make video games, and I'm like, although I like drawing, I know I'm bad at it, and I don't
Yeah.
practice at it, and it's not the most fun thing for me. So I want to learn how to make computers make graphics, and I mean, since I was in my teens, I've been working on generative art, and I think that's why you could say this whole rectified flow thing is just an efficiency gain, and it is just an efficiency gain, but it enables me to start creating art again on my computer and training on my computer because it's so easy and it's so efficient that it's
Yeah.
just feels really liberating. And I feel like I'm back to being 18 again and trying to generate. Well, Grand Theft Auto wasn't out back then, but we had an idea of something like that, like generate a city and do that kind of stuff. So it's
Yeah.
fun to get back to these roots.
Totally. That would be so fun. Yeah. The possibilities. Every time there's a new evolution, right? It gives you some possibilities of doing some really cool
Yeah.
stuff. But I love it.
All
right.
Thanks for letting me
Anything
nerd
else?
out on ML. No, it's just enough agents. They're not called agents. That's what's also nice about them. They haven't been called agents yet, but it's fun to actually nerd out on the ML part of AI.
No, totally. I like it. I mean, it's important to understand how the stuff works under the hood. I always say, so go do your
Oh,
machine
wait, I
learning
should
and
add
your
one more thing. I did promise we'd talk about LLMs, so I'll just end on this. Apple has a new large language model,
oh,
and they're using flow matching
oh,
to generate the text. So most large language models generate the next token, next token, next token. You run it for each token, run it for each token. What if you just generate all the tokens all at once? Oh, that sounds wonderful. But we can't use diffusion because that requires 1,000 steps. That would take forever. So to generate 1,000 tokens, you still have to do 1,000 steps. But here comes rectified flow. In 10 steps, I can generate 1,000 tokens. And Apple actually has neural networks on GitHub that do exactly this. So Apple is looking at using these flow matching rectified flow stuff specifically for large language models to be a more efficient way than the autoregressive models we're using today. So there it is. I brought it back to LLMs. Not an episode can go by where we don't talk about them.
does that mean faster code generation in our future?
Pretty much. It is a coding model they released.
Oh, wow. Nice. Yeah.
Yeah.
I think that would be interesting as well. Like when all these models, evolve even faster. Like right now, we're all just worried about context windows and speed
Yeah.
and this and that and all these things and blah, blah, blah. And there's fast models, there's this model and everything that. It's like, I don't know. I just want to write some code. Just like, let's get it done. But, all right, cool. Well, let us know if you're generating sweet images. There's like some piece of tech that you're really into. Like, I use a bunch of different things. I'm always interested in how people are generating stuff and making cool art, maybe build some cool games with this stuff. Let us know. Go to mergeconflict.fm. You can also most likely just go to our YouTube channel, youtube.com/@mergeconflictfm. Let's see. We got some people there. We got 863 subscribers. Well,
Ooh,
it's pretty good.
thank you, everyone.
Our watch hours are up. We're trying to hit monetization on that pup. We came to the YouTube, even though we have 500 and some odd podcasts, we came to the YouTube pretty short. We are at 66% of our quota for public watch hours for
Okay.
monetization because they changed all their policy. So we have to hit
Ah,
3,000 watch hours.
okay.
That's quite a lot.
Everyone
But
pick your favorite video and watch it on loop.
yes, but we're up, we continue to grow, I would say, and I really appreciate everyone watching and listening to all the pods, that have been coming, and if I look at the 365 chart, the watch time is up 25% year over year, views up
Fantastic.
10% year over year. So I really appreciate it. It's just nice to get, Frank and I've been recording the same way pretty much almost since the jump. And we get to see each other every single week,
Mhm.
but now you get to see us on. It's really not that special. I mean, it's special to see us, but it's not
It's
like it's
very
like.
special, James. Very
I mean, it's
special.
it's not like it changes the podcast. It's not like we're a professional. Like someone like asked me, like, "Oh, what if like you just like become a professional podcaster and like retire?" I was like, "No." And I was like, "Oh, they're like, oh, you must like do so well as podcasts." I was like, "Well, we only put as much into the podcast as like we have time for, which is like real podcasters like syntax podcasts, like they got clips and this and that, and they got intros, they got this. So it's like we
Editors.
we don't got time for that, right? Like I got day jobs, so it's hard. So we appreciate everyone being here. But that's gonna do it for this week's Merge Conflict. So until next time, I'm James Montemagno.
And I'm Frank Kruger. Thanks for watching and listening.
Peace.